Interval vectors. Okay, I've had a lot of questions about these. I'm going to see if we can get this figured out here. Okay, first, when you're figuring out an interval vector, we'll take a collection of pitches. For right now, let's just go over to, let's see here. Chapter 1, Section 8. Section 8, 1A. So, or Section 8, 1A. Okay, our, let's see, the set that they give us is 0, 1, 3, 4, 6, 7, 9, and 10. Now over here I'm going to make a chart of the possible interval classes that we could have. Okay, and I'm going to go number by number. You don't have to do it this way, but this is the closest to how it's described on, I believe, page 14. I'm not going to do it with the staff there, but just check this out and see if you can follow along. So, okay, what we want to do to find out the interval vector of a collection of pitches, we're going to take our group of pitches and figure out how many times each interval class is present within this collection. So first we're going to go 0 to 1, that's a 1, and I'm going to put just a little hash mark there. 0 to 3 is a 3, 0 to 4 is a 4, 0 to 6 is a 6, 0 to 7, it's an interval of 7, but it's an interval class of 5. Okay, 0 to 9 is an interval of 9, but an interval class of 3. Okay, and 0 to 10 is an interval of 10, but an interval class of 2. Okay, so that's what we have for 0. I'm going to put 0 out here because that's going to help me remember that I got those from 0. So I've already done 0. So we're done with 0. Next, we're going to find out all the intervals between 1 and every other number. So 1 to 3 is a 2. 1 to 4 is a 3, 1 to 6 is a 5, 1 to 7 is a 6, 1 to 9 is an 8, is an interval of 8, but an interval class of 4. 1 to 10 is interval of 9, but an interval class of 3. Okay, and that was for 1. So we're done with 1. Now we're going to do 3. 3 to 4 is a 1, 3 to 6 is a 3, 3 to 7 is a 4, 3 to 9 is a 6, and 3 to 10 is a 5 because it's an interval of 7, but it's an interval class of 5. Okay, we're done with 3. We're going to go to 4. 4 to 6 is a 2, 4 to 7 is a 3, 4 to 9 is a 5, 4 to 10 is a 6. Done with 4. Okay, 6. 6 to 7 is a 1, 6 to 9 is a 3, and 6 to 10 is a 4. Done with 6. 7. 7 to 9 is a 2, 7 to 10 is a 3, and then finally 9. 9 to 10 is a 1. Okay. So we have all of those that's all the intervals, and 10 to 10 is a 0, of course, so same thing, 0 to 0. Those don't count. So we take all of those interval classes that we've determined from doing that. That's finding a vector. The interval class vectors here is taking each, just coming up with a total number of possible intervals between all of these pitches. Okay, so here we go. We're going to add these together. So all the ones, 1, 2, 3, 4. Twos are 1, 2, 3, 4. Threes are 2, 4, 6, or I'm sorry, 2, 4, 5, 6, 7, 8. Fours, 1, 2, 3, 4. Fives, 1, 2, 3, 4. Sixes, 1, 2, 3, 4. Okay, that's really cool. A 4, 4, 8, 4, 4, 4. This is a very interesting collection because it's just, look how evenly the distribution is of intervals. There are many, many minor thirds in this, okay, with the interval class of 3, which is also 9s, which are major 6. So it's going to have a certain sound to it, but it's got every other interval class in it. So it's, you know, this is going to be some kind of a scale. It's got 1, 2, 3, 4, 5, 6, 7, 8 pitches in it. So my guess is going to be that this is an octatonic scale. By looking, I'm just guessing that 0 to 1, we have an octatonic scale. Is a really interesting collection of pitches because it goes half step, whole step, half step, whole step, half step, whole step, half step, and then of course back to 0, which is a whole step. So, you know, for fun, if you're bored one afternoon, go ahead and sing an octatonic scale. You can use a fixed dose system if you'd like, or whatever. Law is good, or sing the note names. That's also good. Okay, so I hope that explains what an interval vector is. You don't have to come up with the fact that this is an octatonic scale, but you can certainly come up with the interval class vector now. That's it on interval class vectors. I can do another one, but we'll see how this one goes.